So we are going to transform our quadratic functions today, okay? Last class we ended with vertex form, okay? Vertex form is y equals a parentheses x minus h squared, because you have to have an x squared, plus k. You have to have an x squared to be quadratic, okay? Where do you find your vertex? It's called vertex form because you can find the vertex in vertex form. The number in the parentheses with x is your x value of the vertex. What do I notice is in front of the is in front of the h though? A negative, so I don't take the value, I do the opposite. So whatever number is in the parentheses with x, take the opposite of it, and that is the x value of your vertex. Then the constant out to the side, that is the y value of your vertex. Heidi, do you have your notes? So, just like we talked about last class, what is the most important point on a quadratic function? The vertex. That's why we like vertex form. We don't have to graph this. We don't have to find the table. It literally is in the equation. Okay? We're able to find the most important point of our quadratic just by looking at the equation. Okay? So, last class also, did we go over that y equals x squared? That's your parent function? Y'all did. Somewhere. Your quadratic parent function is y equals x squared. Because what's the only thing you have to be a quadratic, guys? An x in the equation. An x squared. Okay? So that's why this is the quadratic parent function. Okay? I'm going to graph that in blue. Okay, so this is my parent function. Are there parentheses? So what's the number in the parentheses with x if there aren't even parentheses? There's nothing. Nothing. 1 means you have 1. 0. Is there a constant out to the side? No. So what's the y value of the vertex? Nothing. There's nothing out to the side. 0. So my vertex for my parent function is 0, 0. Whenever we draw our tables, the vertex always goes in the middle of the table. The vertex always goes in the middle of your parabola when you graph it. Okay? How can you pull up other values to graph, guys? Go to your calculator. Pull up the table on your calculator. I'm going to type in y equals x squared. Let's all do this on our calculator. Y equals x squared. Go to the table. What's right below 0, 0? 1, 1. What's right below 1, 1? What's right above 0, 0? And what's right above negative 1, negative 1? Okay, your table should always show symmetry. What does it mean? The top and the bottom y values match. Go in. Those y values match. Go in. Your vertex is in the middle. Does your vertex have a pair or a partner point? No, that's the only one that doesn't come as a pair. That's your one unique point on your parabola. All other points on the parabola has a pair. Okay, what do I mean by a pair? Same y value. Okay? So let's plot this. Let's graph this. When you draw your parabola, make sure you extend it all the way through the graph. and arrows go at the end of your parabola. How can I check to make sure I graphed this correctly? Hit the graph button on your calculator. They should match. Do they look the same? Yes. Okay. We go with our parent function. Now we are going to compare it to this one. I'm going to rewrite my vertex form above this so it's easy for me to see what value changed. Where am I getting this equation? That is just your that is just your vertex form of your quadratic function. Your vertex is HK. What's the number in the parentheses with X? -2, but we do the opposite, so it's +2. Is there a K out to the side? No, so what's my K? 0, so my vertex is at 2, 0. Okay, I'm going to leave in my parent function because we're graphing two functions on the same graph because we're going to compare the two. So I'm going to arrow down to y2 on my calculator. So we're all on our calculator and we're arrowing down to y2 to put in our second function. Correct, Yusra? We're on our calculator. Correct, Leo? We're on our calculator, arrow down to y2, and we're going to put in parentheses x minus 2 squared and we're going to go to the table. Now what's the y1 column mean, guys? The first one I put in. So what's the y2 column? The second one. That's the one I'm trying to make a table of. So I'm going to look at my y2 column. So again, we always start with our vertex, which go down. It's 2, 0. What's right below 2, 0? 3, 1. Make sure you're looking. Notice how I'm color coding, guys. This is the red function on my calculator, and I'm doing it in red. Okay, go down, and what's right below 3, 1? 4, 4. Then what's right above 2, 0? 1, 1. What's right above 1, 1? 0, 4. That's why I like these new calculators where it's color-coded, okay? So let's plot our points. 0, 4, 1, 1, 2, 0, 3, 1, 4, 4. And draw your parabola. Okay, so, like I said, today we are talking about how one function changes to get the next function. So from my blue graph to my red/pink graph, how did the graph change? What did I do to this blue graph to then get this pink graph? It moved which way? So we're not going to say move, we're going to use the word shift. So it shifted right 2 units. We okay with that? If I took this blue point, move it 2 to the right, 1, 2, I'm now at the pink. Take this blue point, 1, 2, I'm now at the pink. Take the vertex, 1, 2, I'm now at the pink. 1, 2, I'm now at the pink. So every point is shifted right 2. Do we see that? Looking at your equations, what changed? What value? The A, the H, or the K? So the A is the number in front of the parentheses. Is there a number in front of the parentheses on either? So they both have an understood A of 1, so that's not different. The what? The number in the parentheses with X went from 0 to 2. So what do you think shifts you right and left? the h. Okay, so shifting right and left is an h value change. If the h value changes, you're shifting right and left. If it's positive, you shift to the right. If it's negative, you shift to the left. Think about it. Where are positive numbers on your coordinate plane? On the right. So if h is positive, you go to the right. If h is negative, you go to the left. We good with that? Okay. Next one. What am I still starting with? Which is called your parent function. So this is your parent function. Because all it has is an x squared. What's your vertex of the parent function? 0, 0. Remember, vertex is an ordered pair. Can I just flip the page over and look back to what we did for the table? -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Because my parent function doesn't change. Those are the same values. -2, 4, -1, 1, 1, 1, 2, 4. Those are my parent function values. Can I graph that? Yes. Guys, did I graph that super quick? Yes. However, that is literally the same exact function we graphed on the front page. Okay? Because it's my parent function. I'm going to rewrite my vertex form above this. Y equals a times x minus h squared plus a. Where am I getting that from? That is just your vertex form of your quadratic. Okay, we need to find the vertex from my equation. The number in the parentheses with x is your x value of your vertex. But do I even have parentheses? No, so what's the x value of my vertex? 0. The k, the constant out to the side, tells you your y value of your vertex. What's the constant out to the side? -8. It's a negative because it's not in the parentheses. You only take the opposite of whatever's in the parentheses. Okay? We good with that? So my vertex, which always goes in the middle, is 0, -8. How can I find more values to plot? Go to your calculator. Again, since I'm still comparing it to my parent function, I'm going to leave my y1 in as y equals x squared. Okay, because that's the first one that we started with. So go into y2, go into y2, and let's type in our new equation, x squared minus 8. Go to the table. Go to the vertex, 0, -8. What's right below 0, -8? 1, -7. What's right below 1, -7? 2, -4. Okay, what's right above 0, -8? -1, -7. And what's right above -1, -7? -2, -4. Do my top and bottom y values match? Go in, do those y values match? Go in, is my vertex in the middle, not with a matching pair? Yep. This is how your table should always look for a quadratic. Okay? Plot your points. Okay, what do we notice is the difference between my parent function, the blue one, and my red one? And we're not going to use went down. What's the same word we used on the last problem? Shift. Okay, so this shifted down how much? But down means negative, so don't say negative. So just shift down 8. This time, what changed in the equation? The h was still 0, but the k changed. So what do you think shifts you up and down? A k value change. If k is negative, you're going to shift down. If k is positive, you're going to shift up. Okay? Think just like on your coordinate plane. Negative numbers are down, positive numbers are up. So if k is positive, you shift up. If k is negative, you shift down. Good? Okay. We have 2 more changes. Okay, there's 4 different ways our quadratics can change. We've done 2 of them. The h shifts you right and left, which if you think about it, the h is the x value of your vertex. X is your right and left axis. K is the y value of your vertex. Well, y is your up and down axis. So does it logically make sense that the h, which is your x, is your side to side, and the k, which is your y, is your up and down? Okay? And you can always just graph it on the calculator as well. Okay? Because on your test, guys, on your homework, do you really think that you need to graph both functions by hand to determine the differences? No. Not at all. Can you graph both of them on your calculator and compare and contrast the parabolas? Yes, I'm just trying to help y'all discover how the a, the h, and the k change our functions. Okay? Next one. Oh, look. This is still my parent function. I'm just going to call it the parent. So that's my vertex of the parent function. 0, 0. Can I just copy this same table right down here? Yes. Okay, so above the y equals 2x squared, I'm going to put y equals a times x minus h squared plus k. Is there a number in the parentheses with x? No, there's not even parentheses here, are there? So what's the h? 0. Is there a constant out to the side? Is there a plus or minus number out to the side? No. No, so what's your k? 0. So the vertex is still at 0, 0. That did not change because the h didn't change and the k didn't change. So my vertex is not moving. The vertex is still at the origin. Okay? So let's go to y equals on our calculator. Keep your parent function in. And I'm going to type in 2x squared. Okay, what's right below 0, 0? 1, 2. What's right below 1, 2? 2, 8. What's right above 0, 0? Negative 1, 2. And above negative 1, 2? Negative 2, 8. I did that wrong. Make sure you plot correctly. hard to correctly compare the graphs if you don't correctly graph them. Okay, so I didn't shift right or left. I didn't shift up or down. My vertex is at the origin, just like it is on the parent function. No shifting happened. But what did happen to your graph? They're clearly not the same. The points are not all directly on top of each other. Their equations aren't the same, so they're not the same function. What's different? So we are not going to say shift, because shift means that like your vertex is moving. Okay? But it went inwards. Okay? It got narrower, skinnier. Okay? So what we call this is we call this a vertical stretch. Because we got taller and skinnier. Okay, think vertical stretch is tall and skinny. What would a vertical compression be? Fatter. Think short, fat, tall, skinny. Okay, vertical stretch, tall, skinny. Vertical compress, short and fat. Okay. Looking at your equations, what changed? The 2. The 2 is your what value though? The A. It's the coefficient of your x, so it's your A, okay? So this is an A value change. Would I accept words like it got skinnier, it got narrower, it vertically stretched? All of those mean the same thing, okay? However, like on your test, if it's multiple choice, on the STAR test, it's going to use the verbiage of vertical stretch. Okay? So you need to think narrower means you're getting vertically taller. Good? Last one, guys, of these. Then we're going to put all this knowledge to use. Oh, wow. What are we starting with on number 4? Which is your parent function. Good job. So my vertex is at 0, 0. And I can just copy the table of the parent function above it. Negative 2, 4, negative 1, 1, 1, 1, 2, 4. Where am I getting those values? Those are the same 5 points I plotted now 4 times. 5 times? 4. Those are your quadratic parent function points. Now I'm going to write equals a times x minus h squared plus k. What's my h? What's the number in the parentheses with x? 0. There is no number in the parentheses with x. What's your k, your constant out to the side? 0. There is no constant out to the side. So my vertex is still at the origin, 0, 0. Let's go to our calculator to find more values. My equation is y equals negative x squared. Okay, what's right below 0, 0? 1, negative 1. What's right below 1, negative 1? 2, negative 4. What's right above 0, 0? And what's right above negative 1, negative 1? Plot your points. Okay, looking at these two graphs, what's different? Okay, do you think in math, does flip sound mathy? Reflect? Is that what you said? Reflect? We reflected over, yes, Dominic? Convert, okay. So reciprocal is whenever you're talking about a fraction, okay? So we're going to use the phrase reflect, but whenever you reflect, you have to tell it how to reflect. What did we reflect over? The x-axis. So this reflect over the x-axis. Is that the only change? Is the vertex in the same spot? 0, 0, 0, 0. No shifting happened. Okay? Did it get skinnier or lighter? No. Okay? If you look at the values, -4, +4, -1, +1, 0, 0, 1, -1, and 4, -4. The only thing that happened is my y values changed signs. Okay? Let's compare the equations. What's the only thing that changed between the equations? The negative sign. That's a what value? Your a, your h, or your k? The a. So this is the change the a value sign. So the a value affects its width. The sign affects its reflection. Okay? So A affects it two different ways. The sign, whether it's positive or negative, can reflect it. The value, the number, affects its width. Vertically stretch, vertically compress. Okay? So, down here, those 4 changes we just made a little chart out of. Do we know what those bars around the A mean? What do those 2 little jail cell bars mean? Absolute value. What does absolute value mean? Turns all numbers positive. It's your distance from 0. Distance is always positive, so the absolute value of a number is always positive. So, your value of A, not the sign, just the value. If the value of A is in between 0 and 1, it's a vertical, and we're going to actually use the word compression. That's the more mathy word. Oh, wrong color though. Vertical compression. So this is kind of confusing. I like to use my hands. If A is small, the graph gets wide. Okay? So if A is smaller than 1, the graph is going to get wide. Okay? Now if A is bigger than 1, then the graph is going to get narrow. Okay? So if the value of A is bigger than 1, then it's a vertical stretch. Okay? If A gets big, the graph is a vertical stretch, skinny and tall. If A is small, the graph gets wide, which is a vertical compression, short and fat. Okay? Then if A is negative, you reflect over the x-axis. Instead of opening up, you open down. Okay? Which changes your vertex from being a, do we remember what the bottom part's called if you're a vertex at the bottom? What that vocabulary word is y'all learned last class? The bottom, minimum. So normally in your parent function, we have a vertex at the minimum. And then if A is negative, now your vertex is a maximum. Okay? Then H shifts you right or left. If H is positive, you go right. If H is negative, you go left. Say it again. Right or left. Negative's left, positive's right. Do what? It could go either way. H goes left, right. Okay, either way. And then K shifts you up and down, up or down. If K is positive, you're up. If K is negative, you shift down. So there are 4 different transformations we can do with each of these functions. Will you always have all 4? No, we just did 4 examples where there was only one change on each graph. Okay? So, let's compare 2 graphs. We're going to list what are the differences between these 2 graphs. What's the difference between my parent function and then my second function? I will say, I'm sorry, the graphs did not appear super great. Okay, always start with your vertex. Shifting right and left. Okay. From my parent function, did the vertex shift right or left? The vertex is at the same spot? No, it shifted right. How much? I will tell you it's 1, I think. Like I said, it didn't print perfectly. So we shifted right 1. My vertex went right 1. Okay, but if I go right 1, am I at my new vertex? No, what do I now need to do? Shift up 4. Am I now at my new vertex? If I take my original vertex and go right 1, up 4, am I now at my new vertex? Yes, so we're done with the shifting. Okay? But what's another big difference I noticed between these 2 graphs? It flipped. Again, we don't use the word flip though. Reflect over the x-axis. Does it look like they have pretty much the same width? If it's not obvious that like one's way smaller or way wider, assume they have the same width, okay? The width is definitely, in my opinion, the hardest one to find, okay? So those are our 3 changes. How many can there be? 4. We only had 3. Good? Next one. Start with your vertex of your parent function compared to your new function. Is the vertex in the same spot? No, it's not. So what do I need with my vertex to get to the new vertex? Shift which way? Left. And it's 2. Again, any we give you on your test or quiz will be a better graph. Sorry. Shift left 2. But if I shift left 2, am I now at the new vertex? No, I also need to shift down. Anybody want to venture how much we're shifting down? It's 3. Am I now at the new vertex? Yes. Did I reflect? No, but what did I do? I got skinnier, which means that's a vertical stretch. Guys, are we seeing that this is really just compare and contrast? Look at 2 pictures, see how they're different. The major things that you need to make sure you pay attention to is which one are you starting with, which one are you finishing with, okay? Because if I start with this one and I say shift right 2, shift up 3, that's wrong. I'm starting at my parent function. So you have to make sure you're starting at the correct function, okay? Last one. Start at your parent function. And at the second one. Did I shift right or left at all for my vertex? No. But is my vertex at the origin? No, so I shifted up how much? 5. So shift up 5. If I shift up 5, am I now at the new vertex? Yes. Do the widths look pretty similar? You can't compare the widths at the end because there's more of the pink graph on the graph than the blue graph. But if I cut like my pink graph off like that, so the same amount's being shown, does it like those two have the same width? Yeah, okay. Well, what's another difference? Reflect over the x-axis. Are we good with comparing our graphs? Yes? Okay. Guys, could we just graph these? Even though I have equations, could we just graph these to see what they look like? Okay. Look at this second one, though. The second one looks really weird. It says g of x equals 1/2 f of x. Well, what is f of x? What is f of x? What does it say f of x equals right here? X squared. So what can I replace f of x with? X squared. So I'm going to rewrite this as g of x equals 1/2 x squared plus 3. Now, Mr. Barker, like I said, he's my inclusion teacher. He likes to come up with little sayings. I mean, I do too, but he says get the f out, okay? You don't want the f in the function. So you have to get the f out, and what are you replacing the f with? X squared. Okay? Now I have two functions. Can I graph them on my calculator? Yeah, let's do it. I already have x squared. One half x squared plus 3. Graph it. My parent function looks the same as it's looked all along. Okay? So what do I notice from my blue to my red? Shift up. How much am I shifting up? Look at your equation right here. 3. You're shifting up 3. So that let me know I'm shifting up 3. What's another change I notice? The width changed, okay? Well, your A, is that bigger or smaller than 1? Smaller than 1. So if you have a small A, your graph gets wider, which is a vertical compression. So vertical compression. Looking at your new equation, the 1/2 affected it by vertically compressing it. The 3 affected it by shifting it up. Did I put both of those? Are there any other changes in the equation? Those are the only two changes to my graph then. Done. Good? Okay, let's look at the next one. I see that F. You got to get the F out. This one's a little tricky because when I get the F out, I have my parentheses. Where do you think the squared needs to go? On the parentheses. Okay, you always square the parentheses. If you look here, if I square the parentheses, there's only x in the parentheses. So if you just square x, you get x squared. Here, there's two terms in the parentheses, so it's parentheses squared. Are we okay with that? This is probably the trickiest part, is how to rewrite your new equation. Okay? Go to y equals, I'm leaving in my x squared, and now it's negative 1/4 parentheses x minus 2 squared. Guys, you have to have a squared when we're doing quadratics. You have to have a squared term when we're doing quadratics. Are we graphing on our calculator? Again, I told you so much of this unit can be done on the calculator. I don't understand why some of us don't want to take the easy route. We are all graphing this on our calculator. Let's go. Y equals x squared and y equals negative 1/4 parentheses x minus 2 squared. Graph it. So, is my vertex in the same spot? No, so I shifted. From the blue to the red, how did I shift? Which way though? Tell me directions. Right. And how much did I shift to the right? Well, look at your equation. What's the h? 2. Just put it on the, we're done sticking it up there because some of my classes really struggle. That works perfect right there. So shift right how much? 2. Because look, the h is 2. And what does h do? Shifts it right and left. Okay? What's another change? The what? The width. Did I get vertically stretched, tall and skinny, or vertically compressed, short and fat? Vertically compressed. And that's because of the 1/4. Your A is small. When A is small, the graph gets wide. Okay? What else is the difference? You reflect it over the x-axis. And why do we reflect? Why do we reflect, guys? What makes us reflect in the equation? The A sign. Good? Are we liking this today? No. We will get better the more you do. Okay, again, it's comparing and contrasting. There's always 4 things we look for. When we're comparing our shifts, you always just look at the vertex. Okay? Okay. We're going to get the F out and put the squared on the parentheses. So go to your calculator, I'm leaving my y equals x squared, and I'm putting 4x squared minus 7. Graph it. Is my vertex in the same location? So from the blue to the red, how did I move? Shift down, how much? 7. Again, if you don't want to actually count, remember that number, the K, tells you how much you're shifting. Don't say negative 7 because down implies the negative. Shift down 7. Okay, if I shift down 7, am I at my new vertex? Yeah, I just go down 7. Okay, no more shifting. I don't go right or left. Okay, but there is another difference. What's another difference? It's a vertical stretch. We're tall and skinny, so it's a vertical stretch. And that's because my A is bigger than 1. That's because my A is bigger than 1. So I have a vertical stretch. Good? Okay, now I'm going to write equations. And I'm going to change the problem slightly. Okay? Because I only want us comparing to the parent function. So I'm going to cross out this y equals 2x squared plus 4, and I'm just going to put y equals x squared. That's what we're starting with. So write the equation for the function y equals x squared when transformed by reflecting over the x-axis and made narrower by a factor of 3. Okay? So, what does reflecting over the x-axis change? Reflect over the x-axis is whenever a is negative. So I need to make a be a negative number. A is going to be a negative number, because that's what the reflect over the x-axis means. Okay, and then it's narrower by a factor of 3. What affects the narrowness or the width? The A. Okay, if A is bigger, then you are vertically stretched, which means narrower, and if A is smaller than 1, then you're vertically compressed, which means wider. So when it says anything about the width, that's your A, so my A is going to be 3. But my A is going to be what kind of 3? A negative 3, because we have to reflect it and change the width. Are we okay? These are the two changes it says. We want to reflect it, so we're making the A negative. We want to change the width by a factor of 3, so A is 3. So your quadratic vertex form is y equals A times x minus h squared plus k. That is on your formula chart. You will have that for your test. Okay, so now I need to write my new equation. Y equals, what did we say my new A is going to be? Negative, because it reflects, and 3 because it got narrower. Does it say anything about a different h or a different k? No. So do I need the parentheses if there's no h? No, just x squared. Do I need a constant out to the side if there's no k? There's my answer. Could you graph these two to make sure that you reflected and became narrower? Yeah, let's do it. Let's check. Y equals x squared and then negative 3x squared. So when I graph it, it should be reflected and it should be skinnier. And it is. That means I wrote the correct equation. Is the vertex still at the same spot? Yeah, because it didn't say anything about shifting. If it doesn't ever use the word shift, move, translate, your vertex is going to be at the same exact location. We good? Okay. Again, we are starting at our parent function. We want to shift left 7. What makes you shift right and left? And if you don't remember, go back to your cheat sheet. Where do you see the left and right? The H. Okay? So this means H is going to equal, if I go left, is it a positive or a negative? Negative, because negative numbers are to the left. And it's wider. What affects width, guys? The A. So what's my new A going to be? 1/3. Does it say anything else about shifting or reflecting? No, so I have a new H and I have a new A. So again, your vertex form is y equals A times x minus h squared plus k. So I'm going to replace my values with my new values. Y equals, what's A? 1/3. Do I need the parentheses? Do I have an h value this time? Yes. So x minus, what's h? What's h? Negative 7. So minus a negative becomes plus 7 squared. Do I have a k value? No, don't put a k out to the side. Don't put plus anything. So there is my new equation. Can we get our calculator to check? Yep. Don't change the first equation. 1/3 parentheses x plus 7 squared. Does this red one look fatter or wider? Yes. From the blue to the red, did you go left? Yeah, that's what it says, left. Okay, do we like that we can check ourselves? Okay, last one, and again, we're going to change this function. I'm not going to start at y equals x plus 2 squared. We're just going to do y equals x squared. We're starting at our parent function. All the ones on your test will be starting at the parent function, guys. All the ones at your quiz will be starting at the parent function. Okay? So y equals x squared. We want to shift down. What makes me shift down? K. So what's my k value going to be if I go down 5? Negative 5. And I also want to shift left too. What's going to shift me left? The h. And if I go left 2, what kind of 2 is it? Negative 2. Does it say anything about changing the width or reflecting? No. Okay. So I have y equals a times x minus h squared plus k. Guys, it is super beneficial to write this out at the beginning so you then know where to substitute your values correctly. Okay? So y equals, do I have an a written? No. So you're not going to use an a. Parentheses, x minus, what's h? Negative 2, which becomes a plus 2. Squared plus k, but k is what kind of number? So not plus k, but minus 5. Can we graph? Yes. X plus 2 squared minus 5. From my blue to my red, did I go left and then down? Yep. Okay, we good? We are done for today. Again, I am extending last class period's homework by 1 day for y'all. Please get your computer. Work productively. Use this time to ask for help.